In this example, we want to know which of the following is the antiderivative of f of x is equal to the cosine of x squared minus 5. To do this, we're going to actually use the fundamental theorem of calculus to try to help us out. And you can also run through each one to see if you have the correct antiderivative. So if we take the derivative of each choice, a, b, c, or d, we should wind up with f of x. So let's work with the first one here. So we'll take the derivative of, with respect to x, the sine of x squared minus 5. We have a different function inside the sine, so we're going to need to use the chain rule here. So that'll be the cosine of x squared minus 5, keep the inner function the same, then times the derivative of the inner function. You can see that in our f of x expression for f of x, there is no 2x right there, so this guy can't be it. We'll try a different color here for the next piece. So this one, the derivative of, this one's going to be, let's see, we've got the sine of x squared minus 5 over 2x. And they're trying to fool you here. If you did the first one, they're saying, hey, what if we just dropped a 2x down in the bottom? Wouldn't that cancel with this guy? And the answer is no, that actually doesn't happen. Let's actually work this one here as we find the derivative. Remember, we've got the quotient here, or the division between, or the fraction of these two expressions. So we need to use the quotient rule. So we'll go low, d high, so that was cosine x squared minus 5 times 2x from before, minus high, which is x squared, sine of x squared minus 5, d low, which is times 2, that's the derivative of 2x, all over the bottom squared, so that's 4x squared. Not much here is going to cancel out, and so this definitely is not f of x, so this guy is not the answer either. Once again, they're trying to trick you if you did the first one by saying, well, doesn't the 2x just cancel out? And the answer to that, of course, we just said is no, it doesn't. All right, let's work with the other two. And to work with these other two, we're going to need to use that fundamental theorem of calculus. So what we're going to do when we have an integral here, and we want to find the derivative of that integral defined function. So we've got from pi to x squared as our upper limit. Then we've got the cosine of t minus 5 and then dt. What we're going to do is we're going to take our integrand, which is this guy right here, and we're going to substitute in that upper limit. Here's your upper limit for the t, so that'll be x squared minus 5. So at first glance, this is going really good. I'm taking another look here at f of x is equal to the expression for f of x. I'm like, all right, sweet. But the thing here that is going to cause some problems is we have to multiply by the derivative of the upper limit, which happens to be 2x. So this one doesn't work either. Now you're probably thinking, well, gosh, it's got to be the other one. Well, yes, of course it is, but let's actually show that work. Why is that? So let's find the derivative with respect to x of this integral defined function. Now we've got t squared minus 5 on the inside dt. And we'll do the same thing that we did before. So we'll take that integrand, which is the cosine of t squared minus 5. We'll substitute the upper limit in. Now your upper limit is just x. And then we'll multiply by the derivative of the upper limit. When we do that, we wind up with this particular expression right here. And if we look above, that actually is the expression that we want for f of x. So choice D is definitely correct. We've eliminated the other three and proven that choice D is the one that we want.